Alright, in this video we're going to be talking about perfect squares and their square roots. And so we have a statement written here, and it says a perfect square is the product of squaring an integer. The square root of a perfect square is a rational number. Alright, what does that mean? Well, very simply, if you recall, an integer is a whole number and its opposite. In other words, it's the negatives. And if I square it, what I'm going to get is a perfect square. And so let's take any whole number. Let's take ones like 4. If I take 4 to the second power, that's squaring it, multiplying by itself, that equals 16. And the square root of 16, of course, is going to be 4, which is a rational number. Why is it a rational number? Because I can write 4 in the form of a over b. I can write 4 as 4 over 1, 8 over 2, 12 over 3. These are all equivalent to 4, and they're all fractions. And as you may recall, rational numbers are numbers that can be written as fractions. Let's take a look at another example of this. What if we take something, say, like 11 to the second power? Well, 11 is an integer. If I take it to the second power, I get 121. And the square root of 121, of course, is going to be 11, which is also a rational number. So we said that this works for integers, so why don't we take an integer and square it? What if we take negative 3 and we square that, and what do we get? Well, we would get negative 3 multiplied by negative 3 is 9, and the square root of 9, of course, is going to be 3. All right, so that is a proof of the statement that a perfect square is the product of squaring an integer, and the square root of a perfect square is a rational number. All right, I'm going to pause for a second, and we're going to put up our second statement, and we'll take a look at that. All right, our second statement is that numbers that are not perfect squares have irrational square roots. Okay, what does that mean? Well, that means if I'm looking at a number, say I'm looking at the number 90, and you cannot give me a whole number, an integer, that multiplied by itself, like 4 to the second power, 5 to the second power, that sort of thing, that will equal the number 90. So I know that if I want to take the square root of the number 90, it's going to equal some irrational number. And what's an irrational number? An irrational number is a number that cannot be written in the form of a over b as a fraction. So let me show you what this looks like on a calculator. So I'm going to put my calculator in here, and I'm going to put in the number 90. And I'm looking for my radical sign. It's right here. And as you can see, I get this long decimal. And notice in this decimal that it keeps going. It doesn't have a repeating number in it or a repeating group of numbers. It just goes on forever and does not terminate. So this would be an example of an irrational number. The square root of 2, for instance, would be irrational. The square root of 37 would be irrational. These are all examples of numbers that are not perfect squares that have irrational numbers for square roots. All right, in our next video, I think we'll take a look at defining exactly what irrational numbers are so that you can recognize them.